Okay, so today to um we want to see something about Laplace transformation. So this is a Laplace transform. Okay, so what the Laplace transform basically means is that it will help us to reduce the differential equation into simpler way for us to solve. Okay, so it's just a transformation as the name even self-explanatory. Okay, so basically what we use to do for Laplace transformation is this. We always take the integral, that's the limit from 0 to infinity of e exponent minus st f of t dt. So this what the Laplace actually does. Okay, so this is what the Laplace actually does. So just keep this in mind. So we are just transforming some function of t to some function of x. Okay, so basically, actually, the function was in terms of t, but we are now applying this transformation to convert the f of t or transform the f of t to f of s. So, but we can say this small f, this capital F, there's a huge difference between this and this. Most people mess this up. This is a small f, this is a capital F. So the capital F is what we are transforming the small f into. Okay, so this is the small f, that's the function of the t, that's the actual equation, and the new result is the capital F of S. Okay, so the other way too we can determine or differentiate the small f and the capital F is that the small f2 is of a function t, but the capital F is of the new function S. So this is the old function and this is the new function. Okay. So what we after knowing that we are applying this transformation, we then ask ourselves, how then do we convert or even solve this? So that will introduce us to the idea of limits from calculus. Okay, so we need to understand some basic concepts in calculus. So we can do revision on limits. Okay, so we will take just a limit of a certain number, say h. So as h approaches infinity, the integral of from 0 to infinity of the function e exponent minus st multiplying f of t dt. Okay, so this will make us transform the f of t to the f of x. Okay, so we should know that the f of s is equal to the Laplace transformation of the f of t. That's the function that they will be giving to us. That's the f of t. So when we want to transfer or transform a small f of t or a function f of t to a big f of s, then we have to apply a Laplace transformation. And this is what we intend to do. So the integral from 0 to infinity of e exponent minus st multiplying the function f of t dt. And as I have already spoken about the limits, so we just take the limits from h to infinity, integral from 0 to infinity e exponent minus st f of t dt. Okay, so we just make a substitution. Okay, so we are coming to learn one thing. um we ask ourselves, there are some questions we will encounter in our daily lives as we move on in differential equations. And these are some of the petty things we will come across. Okay, so when you'll be given some e exponent lambda t. So the lambda could be is a constant. So it could be 2, it could be 1, it could be 3, it could be 4. The lambda is constant. So anytime we apply a Laplace transformation of certain function in a form e exponent lambda t, always the result is 1 over s minus lambda. The result is 1 over s minus lambda. Remember, the lambda is the constant. Okay, so without much ado, we just make a substitution. So I just want to prove why am I saying that whenever we apply a Laplace transform for a function in this form, an exponential function in this form, we are getting this. Okay, so I'm coming to prove. That's what I have done here. Okay, so let me explain. Okay, so the idea is that we take the integral from 0 to infinity, then the e exponent minus st, that this is the rule for the Laplace transformation. So this is the rule for the Laplace transformation. Here the f of t is the function within it. That's the e exponent lambda t. Okay, that's the our f of t. Okay, so just bring your f of t here, then you repeat the e exponent minus st. So my f of t is e exponent lambda. Then this is my e exponent minus st. Okay. So sorry, this place to we have t here. What is it? Okay, it's lambda t. Okay, lambda t. Okay, so this lambda t. Okay, so this was the function, that's the lambda t, that's e exponent lambda t, and this is the dt. Okay, so this is an exponential function, this is an exponential function, so we just pick one. Okay, they are multiplying, and the law says when we have two exponential functions multiplying, you just add the exponents. Okay, so here we know that t is here, so we can factorize t out, and we want to make our solution very simple. So we can just multiply. You see, this is minus s, so this is minus s. Then this is lambda. You see, the lambda is positive here, the s is negative here, but we don't want minus s and lambda. So what we intend to do is that we can multiply 2 by the negative, so that the s becomes positive and the lambda becomes negative. Okay, so upon factorizing my negative out, I've not changed anything. This is the same thing as this, because when I multiply negative by the s, you are going to get negative st, and when I multiply negative by negative, you are going to get positive. So this, I have not done anything to the equation. Okay, so we just take the limit from 0 to infinity of, we now come and integrate e exponent negative s minus lambda t dt. Okay, so this is an exponential function. Anytime you integrate exponential function, just maintain the integral function, that's the e exponent minus s minus lambda t. Then you differentiate the numerator with respect to t. Okay, so anytime you differentiate with respect to t, the t is going to yield 1, then it is going to left with minus s minus 2, then you divide. So that's what I've done here. So you are going to get the limit from 0 to infinity, 1 over negative 1 over s minus lambda e exponent minus s minus lambda t dt. Okay, so this is an idea of how we integrate exponential functions. Okay, so we then factorize the constant out. As we can say, or we can boldly say 1 over s minus a, 1 over 1 over s minus lambda is constant, so we can bring my minus 1 over s minus constant the constant lambda out. Okay, so we are getting e exponent minus s minus lambda of t from this limit. So we are almost done. We just take from the idea of calculus. Whenever we have something like this, we just take the limit. So we just it's the upper limit minus the lower limit. So we just make a substitution. So whenever we see t, we just make a substitution for the lambda. Whenever then we take it away from whenever we see T2 we input 0 there. So actually that's what I've done here. So that's e exponent minus remember this is a constant, s minus lambda is a constant. So we just put when we put infinity at where the t is, we are going to get minus infinity. Okay, then we take away minus, then remember I first said the solution for this is the top minus the down. Okay, so this the top and now minus this the down. So just make so e exponent minus, so remember I said we are just putting this limit into the t. Okay, so you are going to get minus e exponent 0. Okay, because the whole of this is a constant, so it becomes e exponent, that's the t, which is 0. Okay, so here you are going to get minus 1 over s minus lambda multiplying, you know that e exponent minus lambda is 1 over e exponent lambda. Okay, so I've done that into the equation, and e exponent 0 is 1, so you are getting minus 1. Okay, so let's simplify this. You know that 1 over infinity, 1 over e exponent infinity, or 1 over infinity is what? 0, and 1 over 0 is infinity. Okay, so just keep that in mind. So the 1 over e exponent infinity will yield 0. Okay, so the whole of this place will yield 0. Then also my minus 1 over s minus lambda multiplying minus 1 to negate po. So you are going to get positive. Okay, so that's what I've done here. Okay, so you are going to get positive. So hence we've proved, yeah, we have been able to prove that whenever we um, take a Laplace transformation for e exponent lambda t, we are going to get 1 over s minus lambda. Okay, so understand the concept very well. So let's see how we can use the idea to solve some questions. Okay, so there's a question for you guys. We should take a Laplace of e exponent 2t. So as I said, the constant here is the 2. Remember, that's the lambda. The constant here is 2. So you are going to get 1 over s minus lambda, and the lambda is the constant, which is 2. So you are going to get 1 over s minus 2. So this becomes your answer. Very simple. Okay. And I to Laplace of e exponent 5t, the same procedure. You are going to get 1 over s minus lambda, and the lambda is here, that's the constant, which is 5. This is the lambda 5. Okay, so you are going to get 1 over s minus 5. Okay, so that's the answer. You are done. Okay, so there's no need for you to go to the procedure, all this, but you have to understand. Okay, so sure. And note, one important thing I want to discuss with you guys is whenever we have a Laplace transformation of one, a constant one, we are going to get 1 over s. So anytime we apply a transformation on 1, we are going to get 1 over s. So why am I saying that? So Laplace transformation of 1 can be written as e exponent 0. Okay, so e exponent 0 is 1. Okay, so you can just verify. So just know that here the constant now becomes the lambda now becomes 0. So you are going to make a substitution here. You are going to get 1 over s minus the lambda, which is 0. So you are going to get 1 over s. Okay, so anytime you have a Laplace transformation of 1, you are going to get 1 over s. Thank you.